Alright, one of the things we cover in this class are different ways of expressing a set of numbers. In the last video, I talked about what a set is. And one of the ways you can express a set is with set notation. A set notation basically uses these curved brackets to list the members. So if you have just single members, you might do the set of numbers like this. There's also subsets that are also sets. They are you can tell because of the curved brackets. You can also use set notation for not just individual numbers, but for a whole range of numbers. When you have it that way, it's set up like this. You open your curved bracket, and then you basically identify what's in your set. So you have your x or y if you're dealing with range or whatever variable. Then this line means such that. And then whatever your conditions are, whatever your x or y or whatever variable has to be, that's where you list those conditions. So for example, this says I've got a set of x values such that x is an odd number and it's an element of the real number system, or it belongs to the real number system. If you see this, basically this means that it belongs to whatever set is behind it. So for instance, this one is saying I've got a set of x values such that x is an integer but not equal to -4. So it's every integer except -4. So this is a good way of defining a large set of numbers, an infinite set of numbers that might have some exceptions. Another way to represent a large group of numbers is with interval notation. It's not quite the same as set notation, but we can use both of these to represent domain and range of graphs and number lines. Now, bounded intervals have endpoints on both sides. If your endpoint has a closed dot, it means it includes that number, and we use the straight braces to show that it includes the number. If we have an open circle, it means it doesn't include that number. It gets close but never reaches that number, and we use a parentheses with that. An unbound interval only has one endpoint. One side goes to infinity or negative infinity. And with infinity, because you can't reach it, you use a parentheses. So for example, here I have a bounded interval going from A to B. It can represent numbers. It can be 1 and 2. It can be 5 and 10, whatever. But we have an open circle at A, a closed circle at B. So the interval notation, we always go from small to big on your interval notation. A, because it's open, we have a parentheses with it, comma, B is where it ends, and because it includes B, we use a straight bracket. In Algebra 1, you might have seen a number line like this and have the range of numbers expressed as an inequality that looks something like this. These two things say the same thing. For the set notation version of this, it's not much different from the inequality. You open your braces because the set notation includes the braces. So it's the set of x values such that A is less than x is less than or equal to B, and then close your set. So it's just your inequality in set notation. So let me show you an example of an unbound interval. This one starts at A and includes A, and it goes to the right forever. It gets bigger forever and goes on to infinity. So it starts at A, and because it's closed, we use a bracket because it includes a. On the right side, continues to get greater without limit, so it goes on to positive infinity. And since you can't actually reach infinity, we use a parentheses to close it. Now, as an inequality, we express this as the x value greater than or equal to a. Because for inequality symbols, these are going to be your or equal to's. These are going to be the not equal to's. So for set notation of this number line, start your set. It's a set of x such that x is greater than or equal to a. So if you want to pause the video and try some of these, go ahead. I'm going to go ahead and talk through. We have a number line here, bound on two sides with open circles. So we use parentheses on both sides of my interval notation. Starts at a, goes to b. My inequality would be a less than x less than b. And set notation would be the set of x such that a is less than x is less than, whoopsie, it's just less than b. So if I have interval notation says it goes from a to infinity, well, this is my small, this is my big, so it's the lowest is here at a, and the parentheses tells me it's an open circle. This positive infinity tells me it goes to the right without limit. The inequality for this would be x greater than a. And the set notation would be set of x such that x is greater than a. Okay. I'm going to change this to greater than or equal to, because I just realized that that's the same thing as that one. So we're going to change that. Okay. So if I have x greater than or equal to a, the only difference really is that we have a closed dot on a and a straight line bracket on my interval notation. And then set notation, you have this part, and then you do your inequality. Now this one, going from left to right, small to big, the first thing we see is the arrow. This means it keeps getting smaller and smaller without limit. So where does it start? Well, it doesn't really have a starting point. It goes on forever. So we say that it starts in negative infinity. And the biggest it goes to is b. And because it's open, it can't actually get to b, we use a parentheses to close it. So for the inequality, we say that our x values are less than b. Here's a little tip. If you start an inequality, if it's unbound on one side, if you start the inequality with your x or your y or whatever variable it is, your inequality symbol points in the same direction as your number line. Okay. So continuing on to the set notation, this would be the set of x such that x is less than b. Now this last one says that x is it's the real number set. X is an element of the real number, so it's all real numbers. If it's all real numbers, some people like to do an inequality for it. I don't like to do an inequality for all real numbers. Interval notation for this would go from negative infinity to positive infinity. And the number line would be unbound on both sides. Now you can also use all three notations to express domain and range of a graph. It doesn't have to be number lines, it could be a graph as well. So for instance here, my domain, my x values, left and right, it goes left and right without limit. This means the domain is the set of all real numbers. So interval notation would be negative infinity to positive infinity. I'm not going to do an inequality for this. but the set would be set of x such that x belongs to the real number set. Range is your y's. That's your up and down. Now, the lowest it can go is what you start with, but there is no limit to how low it goes because it goes down forever. So that means it starts with negative infinity. But the highest it goes is here at 3. And because it can actually equal 3, you use the straight lines to close your interval notation. Now for your inequality, because we're dealing with range, it's your y. All my y values are below 3 or equal to, so less than or equal to 3. And then for your set notation, it's the set of y values such that y is less than or equal to 3. Okay. So a few more. This one, it's bound on one side but not the other. So domain, remember this is your x's, your left and right. The furthest left it goes is here at negative 3. So it starts at negative 3 because we go from small to big on my interval notation. And because it's an open circle, we start with the parentheses, negative 3, and it goes to the right forever off to positive infinity, close with the parentheses. So all my x values are greater than negative 3. Set notation, it's the set of x values such that x is greater than negative 3. For my range, on my range, this is your up and down. There's no limit to how far up it goes because it keeps going up and increasing. But the lowest it goes is here where y is negative 2. So my range for my y values, my lowest is negative 2, but it can't actually be negative 2, so parentheses, and it goes up forever, so it goes up to infinity. So this means in the inequality form, all my y values are greater than negative 2, because it's above it. And for the set, it's the set of y values such that y is greater than negative 2. This one is bound on both ends, and they're closed dots. So on my domain, that's left and right. The furthest left it goes is negative 3, the furthest right is positive 2. So straight lines for the interval notation. Lowest is negative 3, highest is positive 2 on the x-axis. For the inequality, we say that negative 3 is less than or equal to x, which is less than or equal to positive 2. Set notation, it's the set of x such that negative 3 is less than or equal to x is less than or equal to 2. Your domain, your range, we just did domain. Your range, your up and down. The lowest it goes is negative 2, the highest it goes is positive 2. So interval notation is negative 2 to positive 2 with the straight lines brackets to close. On your inequality, it's negative 2 less than or equal to y. Be careful, a lot of students get so used to writing x they put an x here, but range is y, domain is x, is less than or equal to 2. Set notation, it's the set of y values such that negative 2 is less than or equal to y is less than or equal to 2. Alright, last example. This should go pretty quick. Left and right, it goes on forever. So interval notation starts in negative infinity, goes to positive infinity. I don't do inequalities for this particular domain, but the set notation, it's the set of x such that x is a real number. Later on in the year, I'm probably going to get lazy on writing this, but it's fine. This is the proper way of saying it. Range, that's your up and down. It goes up forever, down forever. So range is also negative infinity to positive infinity. The difference is, on your set notation, it's the set of y values such that y is a real number. Alright. So, that's it for interval notation, inequality notation, and set notation. See you next time.